Alright, so we're going to go ahead and do this part. So this is adding and subtracting rational expressions. So let me go back to something you should know already. Alright, if I want to add 1/2, if I want to add 1/2 and 1/4, okay, and again, I'm going to get this closer because I can't zoom in with the video recording. So if you have 1/2 plus 1/4, you remember how to add two fractions? Obviously, you should know this is 3/4, but if you don't, then what you need to do is find a common denominator, right? So basically what I'm asking you is, how do I make that 2 into a 4? And remember, the only thing I can do is multiply. So what do I need to multiply that 2 to make it into a 4? 2, right? Simple as that. So if I multiply the bottom times 2, I also need to multiply the top times 2. So whatever I do to the bottom, I do to the top. And that will give me 2 over 4 plus 1/4, which then I can rewrite that as 2 plus 1 over 4, which is equal to 3/4. Alright, so those steps that you see here are basically what I'm going to be doing on here. Alright, now if you already have, so to add a fraction, or to add fractions, you must have a common denominator. Alright, so look at the bottom of those two fractions and those that you're subtracting. Do I have the same thing in the denominator? Do I have the same exact value in the denominator? Do I have an n minus 2? Yes, right? So if I have n minus 2 here and here, I don't really have to do much math. All I have to do is add, or in this case, I have to subtract. And I want you to be careful with that, because notice how I'm writing this. I'm writing this with a minus 3n minus 1, like that, over the common denominator, which is n minus 2. Notice again that I'm not writing the common denominator twice. I'm only going to write it once, like I did here. Okay? And one more time, if I'm subtracting, I have to subtract this and that. So what that means here is that I'm going to switch the signs, not only on the 3n, but also on the 1. And then I add those, I basically add all the like terms in the numerator. Alright, so this would be negative 2n plus 1. All of that over n minus 2. Does that make sense? So if you already have a common denominator, so again, if you already have a common denominator, all you have to do is add the numerator, basically, or subtract it accordingly. Alright, on number 2. Number 2 is kind of similar to what I did there, but the question is, how do I make these? How do I make the denominators the same?
Wouldn't it be 2x squared would just be 4x, so then they both be 4x?
Close. So, let's take it one step at a time here. How do I make this the same? You don't have to write that. That's just for your notes. If you want to write it, fine. If you don't, that's fine too. So I'm going to rewrite this here so I have more space. So I have 1 over 2x squared plus 5 over 4x. Alright, so to answer your question, Austin, almost. Alright, how do I make the 2 into a 4 if I'm only multiplying? Well, I have to multiply this left side by 2, right? Now notice the denominator in this one is going to be 4x squared, and the denominator on this side is just 4x. So then the question then becomes, how do I make this x on my right like this x? Remember, I can only multiply. So basically what I'm asking you is, what do I need to multiply this denominator to make it into an x squared?
1.
X. So we have x, right? So if we multiply x times x, I get x squared. Alright, so notice again, now I'm going to multiply the numerator. I have 2 times 1, which is 2. Up here I'm going to have 5 times x. All over what should be the same denominator. Alright, so make sure that it is the same denominator. 2 times 2 is 4, that's 4x squared. If I go to this side, I should have exactly the same thing. 4x times x is 4x squared, so I do have the same denominator. Now at this point, you need to add the like terms in the numerator, but there is none. Right? I don't have a like term in the numerator, so this is it. There's nothing else you can do. That's the answer. Okay? Now, on number 3, even though they may look a little bit the same, they're not. Alright, x plus 2 and x minus 2, they have nothing in common. And when I say that, what I really mean is there's nothing I can multiply this to make it into this, and the other way around. There's nothing I can multiply these to make it into that. I can't. If I multiply by a -1, that's going to give me negative x plus 2. Not the same. Okay? Almost the same, but not the same, right? So if they're not the same, then what you're going to do, if they're not at all the same, this is actually easy. By that I mean I have to multiply this left side right here by x minus 2. Alright, so I have to multiply this by x minus 2, and whatever I do to the bottom, I have to do to the top. Okay? And I'm going to multiply the right side times this denominator. So it's a little bit more work, but as you can see, hopefully, it doesn't, logically it makes sense to do that, hopefully. Alright, so now look at the numerator. We're going to have 3x minus 2. Notice that I'm multiplying the numerator. And on this one I have -8, and I'm going to multiply that times x plus 2. And all of that is going to be over x minus 2, x plus 2. Alright, notice that I have a common denominator now, right? I don't have to write it twice. At this point, you're going to distribute. You're going to distribute that and this, and then add the like terms. Alright, so this would be 3x minus 6 minus 8x minus 16. All of that over x minus 2, x plus 2. And then you're going to add the like terms. So in this case, you have a like term of 3x and -8x. So that's -5x. And now you're going to add -6 and -16, which would be -22. So I have x minus 2, x plus 2. Like that. Alright, let me get closer here. So that's what you would have. I don't have like terms up here, so that's actually my answer. There's nothing else I can do. Sometimes you can reduce, but I would suggest that you didn't reduce anything, because that's where students tend to make mistakes, alright? Now, I know that I told you, well, you're going to need to know how to factor, but you haven't done any factoring yet. Alright, so let's look at number 4. Let me see, you just came off a test where you had to factor. Alright, so step 1, you need to factor the denominator. Do not factor the numerator. Numerator is not that important. Alright, so the denominator is what we want to factor. Robert, you look like you're half asleep. Hold on, come on. It's alright. I'm not blaming you for it. How do I factor x squared minus 9?
You do x minus 3, x plus 1.
Oh man. This guy knows how to factor. I don't know what you said, but I'm going to ignore you. Alright, so we have this right here. Alright, so I haven't done anything that I've talked about, right? All I've done is factor the denominator. So now then the question for you is, I asked this out of Austin since he's got a lot of things to say. Alright, look at the denominators, Austin.
Yeah.
What do I have on my left side that I don't have on my right side?
X plus 3.
Right, so if I don't have that, then what I'm going to have to do is multiply this times x plus 3, and if I do it to the bottom, I have to do it to the top. So for me, it's a lot easier to do this type of rational addition, because it's easier for me to see what I'm missing. Now to look at the denominators again. The denominators are exactly the same. X minus 3, x plus 3. Alright, so This one, there's no need for me to do anything with this, but on this one, I'm going to have to FOIL this, all right? So you're going to have to FOIL this. So FOIL that. Now, I'm going to make a big assumption that you know how to FOIL, but this is what you would get, all right? If you FOIL, this is what you get. Now, on the bottom, remember, I already have a common denominator. So this is what I have for my common denominator. And then all you're going to do is add the like terms. So notice that my like term on this one is just that one and that one. They're the same. Or they're like terms, I should say. So we have x squared plus 4x minus 21 all over x minus 3, x plus 3. Now, if you do it like this, I am perfectly happy with this answer, okay? So I'm perfectly happy with this answer if that's what you get. There is a possibility, okay? On this one, you can factor the numerator and simplify this even more. Can anybody tell me factors of 21? One positive, one negative, they add up to 4. Or meaning you have one, they subtract to 4, I guess.
7 and 3.
7 and 3, right. So we have 7 and 3. Okay. So then, let me make sure I'm doing this right before I move on. Yeah. So this x minus 3 cancels, and you end up with x plus 7, x plus 3. All right. However, like I said, here's the danger with that. I don't necessarily want you to cancel anything a lot of the times, because for many students what ends up happening is they do this. Okay, they're like, okay, Mr. Ochoa said look for what's missing. Okay, the x plus 3 is missing, and they put it on there. And then the very next step they do is they cancel this. Like, oh, wait a minute, that cancels. You end up with the same problem. You ended up you basically are going backwards. Does that make sense? So if you get to that point, okay, I'm happy. Don't do anything with that. Does that make sense? I'll take that as the answer. If you want to keep going, that's fine. I mean, I'll try to help you out here. All right, same thing on number 5. It's really hard for me to ask you, how can I make this x plus 6 into x squared plus 4x minus 12? I don't even know. All right, so the way to do that, again, is to factor the denominator, because that's easier to look at. So if we factor the denominator, well, first of all, there's nothing to factor on this part. But on this one, again, factor only the denominator. This would be x plus 6, x minus 2. Agreed? Okay, this is, again, assuming you know how to factor. All right, now look at the denominator. Same K. What am I missing on my left side? All right, so we're going to multiply top and bottom by x minus 2. Okay. Now look at the denominators. They're the same, right? The denominators are the same now. So if we have that, again, you have to FOIL here. I know that I'm probably going to be able to do this a little bit faster than some of you. All right, but again, you would have to FOIL this part again. And you have to FOIL because you have 2 terms on each one. You have 2 terms here, 2 terms here. All right, so we have x times 2x, that's 2x squared. And then we have x times 3 is 3x. Minus 4x, that gives me a negative x. And then negative 2 times 3 is negative 6. Okay, and then just be careful. Remember that this minus right here, that's going to subtract both the x squared and the 3. Are you awake over there? You can do it, man. I believe in you. Can you not see? Do I need to move you up? I see you squinting when you're trying. You're like, let's not go there. Alright, so we have negative x minus 9. X minus 2, x plus 6. Alright, you'll settle down now. We're almost done. Alright, so that's the answer for that. You just have to add like terms. Alright, finally, this last one, number 6, I'll go through it really fast. right? On number 6, I like these better. Honestly, I like these better than these because sometimes I feel like I have to do more work on these. But again, how can I make this 5 into a 25? Multiply by 5, right? So let me rewrite this here because I need a little more space than what I'm given. So I'm going to multiply this times 5. I'm going to use a different color. 5 over 5. And then notice, do I have an x squared on the right side? I'm talking about just the numerator. Sorry, the denominator. Do I have an x squared here in this over here? I don't. Right? Then because I don't, I'm going to multiply top and bottom by x squared because that's what I need. Okay? So I have an x squared. And then finally on this one, notice that I have a y squared here, but I only have a y here. So how can I make this y into a y squared if I can only multiply? What do I need to multiply that times? Yeah, multiply by y top and bottom. Alright? And if I have that, this is going to give me 15y plus 6x cubed all over 25x squared y squared. Again, notice that this right here came from multiplying either this one or this one. This should get the same thing. 5 and 5 is 25. Y times y is y squared. X squared is right there. Okay? You want to do a couple of your homework? Let's do a couple of our homework problems. All right, if we go through our homework. All right. All right, on this homework right here, notice that the first 4 problems, 1, 2, 3, and 4, you already have a common denominator. You have a 10x cubed y squared on both of these, so you don't have to find the common denominator. It's already there for you. So all you have to do is add or subtract. In this case, we're subtracting. We're going to add or subtract the numerator. Alright, so notice that this right here would be x minus 5y minus x minus 5y over 10x cubed y squared. Again, please notice that this minus right here, the minus sign, made both the x and the 5y, that made them both negative. Okay? So, this is going to be negative 10y over 10x cubed y squared. Now, you can simplify if you wanted to. You could say, well, that 10 reduces that 10, that y cancels one of those y squares, but I'm okay with you leaving the answer like this. Because that's not, my objective is not for you to simplify. It's for you to be able to find the common factor, right? So that one's easy. All right, let's go to let's do number 6. Sorry, did y'all finish this one? Can I move this one? Let me wait just a second. All right. Let's look at number 6 then. Right, number 6, notice that you have a 4 and a 5 here. All right, the common denominator, since you don't have anything in common there, then you have to multiply this times 4 over 4. You have to multiply this times 5 over 5. I can barely fit it in there, but can you see that? Let me zoom in there for you. 5 over 5 and 4 over 4. Is the denominator the same now? Almost. I have the 20. I'm missing a y squared, right? So I'm going to multiply top and bottom here by y squared, because that's what, I have a y squared here. I need to have a y squared here also. So top and bottom by y squared. This would be 25y. This is going to be negative 8x y squared, all of that over 20 y squared, like that. Again, you can possibly reduce this, but I'd rather you didn't. Alright, so again, this is the answer. Not a whole lot of work to that. Alright. Let's see one more on the back and I'll leave you alone. Alright, some people have been asking about a question like this. Alright, number 10. Now, if you factor this, you can always try to factor the denominator because sometimes that helps you out, that makes your problem easier. So I'm going to go ahead and do that anyway, even though it's really not going to help me on this, but this is 2k minus 8, like that. Alright, so look at the denominators. Do they have anything in common? There's nothing in common. I have a 3 here, I have a 2 here, I have a k minus 8. So what I'm going to have to do is I'm going to have to multiply this right side. Basically, I'm going to multiply by each other's denominators. So I'm going to multiply this right side times 3. So multiply this top and bottom by 3. And I'm going to multiply this left side by 2k minus 8. If I multiply on the bottom, I have to multiply on the top. So that's what I got. And then now remember, I'm going to have to do the multiply the numerators. So I have 14k minus 8. This would be negative 3k plus 6. All of that over, what's my common denominator? What's 2 times 3? So we have 6k minus 8. Alright, and I'm going to have to multiply the numerator. Yeah, I'm going to have to multiply the numerator and then add like terms. Alright, so multiply the numerator, add like terms. So we have 14k minus 112. That's 14 times 8, by the way. And then we have negative 3k minus 18. Yeah. All over the 6k minus 8. And then finally, we're going to add like terms. And I'll zoom in on this one in just a second. I got that one and that one. So I have 11k minus 130. All of that over 6k minus 8. Alright, so that's that. And again, I'm going to go ahead and stop the recording here and see if you got any more questions.